Hey, this is Mr. Beckstrom, and today we're going to do an example problem from section 5.3. This is on exponential functions. So make sure you take a look through that section to learn the rules for exponential and logarithmic functions. Actually, logarithmic functions is the next section after that. But the problem we have here today, with a simple problem, is suppose that we have a function g defined as 6 raised to the x power plus 2. And the first part says, what is our function g um, evaluated at -1? That means when x is -1, uh, what's our y value? So let's go ahead and take a look at this. Get it ready here. So all I'm going to do is we're going to look at g evaluated at -1, which means we pull up that function, and wherever there is an x, we're going to replace that x with a -1. So it's going to look like this. Now we have a rule for negative exponents, and that is if we have a negative exponent, what we want to do is we want to take the base, that's whatever base that exponent is applying to, which in this case is just the 6. We want to put that on the other side of the quotient line. So we can pull it down to the bottom, and we have to leave a 1 on top there. So that's 1 over 6 plus 2. And that's equal to finding a common denominator, 1 over 6 plus 12 over 6. That's just 2 written with common denominator. That's going to be equal to 13 over 6. So when x is equal to -1, y is going to be equal to 13 over 6. So it says, what is the point on the graph of g? And it would just be -1 and 13 over 6, which is a little bit more than 2. Let's check this in our calculator here. So I'm going to go here, and we're going to say 6 raised to the x power and plus 2. Let's try a standard graph here. So we'll do number 6. And as you can see, when x here is -1, it does look like our y value is right there, just a little bit over 2, so that looks pretty good. If I want to hit the trace function and try to get real close to that -1 there, I can do that. You can see that's going to be a little bit over 2. All right, B says if g of x, that's our entire function, is equal to 218, so that means we're going to be replacing our y value with 218. What is x? So if g of x is 218, so we go up to the original function, and I'm going to replace that whole g of x with 218, and that's going to be equal to 6 raised to the x power plus 2. Now there are a few different ways to solve these, but generally we're going to try to isolate the term that has the variable in it, which will be the 6 to the x. So we're going to subtract 2 from both sides. So that's 216 is equal to 6 to the x power. Now at this point we could take logs of both sides, but I think it's going to be a little bit easier in this case, and that is we can write 216 as 6 raised to the 3rd power. Now the reason that that's important is because if we have an equality where the two bases are the same, that means the two exponents have to be the same, and we can set those exponents equal to each other. So I'm going to go ahead and write 6 raised to the 3rd power, which is the same as 216, is equal to 6 raised to the x. And since the bases are the same, the exponents have to be the same. So now I can just write x is equal to 3. So when g of x, or our y value, is 218, our x value is 3, and that point then becomes 3, 218. And that's it. Not too hard. We just we have a few kind of funny looking rules for logarithms, and for exponents, but we do have some tricks in there as well. So if you have any questions, let me know. I hope you have a great rest of your week. Thank you.